a quick appendix video on the metric tensor that'll give us some results that we'll use in the next appendix video. Remember that the metric tensor is this collection of coefficients, this array, Gij, such that our Pythagorean theorem reads ds squared is equal to Gij dxi dxj. And this allows us to use the Pythagorean theorem for arbitrary general coordinates. For rectangular coordinates, we have the regular old Pythagorean theorem, ds squared is dy1 squared plus dy2 squared plus, and so on. And using the Einstein summation convention, we can just write this as dyi dyi. I appears twice in the term, so we automatically sum over it. Now, if yi, these rectangular coordinates, can be written as functions of our general curved coordinates, then we can say y sub I is this function, y sub I of x1, x2, and so on. So examples would be polar coordinates, where y1 and y2 are x1 cosine and sine of x2, or spherical coordinates, where the three rectangular coordinates of flat space, y1, y2, and y3, are related to a radius x1 and two angles x1 and x3. So for example, here are polar coordinates on the left and rectangular coordinates on the right. And using our nifty chain rule from the slope and curvature appendix video, we can write that the change in the kth rectangular component, dy sub k, would be, chain rule, y sub k comma I, that's the slope of y sub k with respect to xi, times the change in xi, dxi. And then if we put two of those factors together, we get dyk times dyk is yk comma I dxi, and then times yk comma j dxj. We already used I to sum on, so now we need to use a different index. We use j. Now we just rearrange a little bit. We pull out the dxi and the dxj, and what's left is y sub k comma I times y sub k comma j. We would sum over k because it appears twice, and that then must be the gij, just looking at the equivalence between the two expressions. So we have then that our metric coefficients would be y sub k comma I, that's the slope of the kth rectangular coordinate with respect to the ith curved coordinate, times y sub k comma j, that's the slope of the kth rectangular coordinate with respect to the jth curved coordinate. K appears twice, so we would sum over k from 1 to 4 in our four-dimensional space-time, or whatever number of dimensions we have. So that'll be a useful expression for us in the next video.